You want to start with the zkTLS story, and then we talk about zkVMs.
Sure, yeah. I liked your introduction that you did last time. You said it very eloquently, bridging this sort of gap or setting the context, I guess, for, the idea maze that that you like brought up last time. Do you want to do like, I guess, brief intro and then we can kind of get into it?
Yeah. So the basically the thought there is that a lot of zk stuff right now is very academic, uh, because things are still being figured out. There's infrastructure still being built, and recently we have seen, like, the spike in just the number of VMs that are being developed, and with that, we get, so once you have like a proper VM, then you can program in a high level language and have have all your infrastructure that you need to generate the proofs, which makes it really accessible for like anyone who can really write Rust or maybe Python, maybe C++, and just make their programs verifiable, uh, which opens up like a really, I think it opens the gate for a lot of developers to really take this highly academic things, and really run with it. you know
Mm-hmm.
so like, as a developer, I don't need to really understand what's going on inside, like how my program is being arithmetized, how the polynomial IOPs work. I don't need to think in terms of constraints or polynomials or anything like that. uh, I can just write a high level program, and everything should work magically. That my computation becomes verifiable. Uh, but then, like, once you have this, like, what you would do with it, right? What are the interesting applications that are actually viable, that one should build? I think those types of questions are quite interesting to me. So yeah, I would love to explore that.
For sure. Yeah, that's a big piece too, is like focus. Sometimes a lot of it, and it feels like sometimes within like the ZK space, you've now, yeah, like you said, you don't need to know ZK and those circuits to get the
Right,
benefits of it anymore, thanks to like
right.
abstractions like a zkVM. Um, yeah, I'm curious. Have you been thinking about like some of the like application or like design space? Like what, um, like where did your
Yeah.
head
So
go?
so funny enough, I was just listening to one of the talk from the Proc Crypto conference last year,
Mm-hmm.
and it was a panel discussion with a bunch of researchers. I think Mary Moller from Ethereum Foundation was there. The Scroll founder there. Like, there were like four people, and I think at one point the discussion went into the topic of applications, and now everybody was like trying to, like, they were trying to maybe speculate, or maybe just trying to encourage people what to build. And I think the two interesting things that stood out to me was like this verifiable compute. Like, I think all four of them were like, very excited about verifiable compute. To me, it's like it's pretty broad. Verifiable compute is like, uh, it's like too broad, right? You cannot
Yeah,
just, what kind of compute, right?
just
It's
computing.
like, yeah, so it's pretty broad to me. I think, um, yeah, to properly define it, you need to really like go into like what kind of compute it makes sense uh, to make verifiable. The other one, the other idea that was discussed in that panel, was the idea of anonymous credentials, something like what Cred is doing. I don't know if you checked out Cred.
I haven't seen cred
Uh,
before.
yeah, so it's like, it's like at least in the current form, what they basically ask you to connect your wallet to their app, and then based on whatever your transaction history is, they will generate some kind of credential, like if you're like super degen, or like or you're not degen enough or something like that.
Mm.
But that's and your wallet address never gets exposed, so um, you just get the credential. But yeah, uh, you never have to leak that that particular wallet had some NFT or not. You just if the credential says that this particular, let's say, Farcaster user FID has this NFT, that means it proves that that the address associated with that as the NFT, and you probably wouldn't reveal, like if you don't want to, you wouldn't reveal that address. So that's interesting. Although it's like pretty. I would say it's not very polished at the moment. Um, it's really early days. Um, yeah, those two ideas stood out to me in that conversation, and related to that, I was listening to another one, another podcast with Justin Taylor and Sam Ragsdale, and they were talking about their backstory with Jolt.
Mm.
And like at one point they were also discussing about their ideas of what kind of applications they want to see. And and I think here, like, ideas are really interesting. So the one that came up was verifiable compilation. So taking the source code and compile it, but what you get as an output, not just binary, but also like a proof that like uh, this compilation is correct.
Mm-hmm.
Uh, so which is like quite useful, because it prevents whole lot of supply chain attacks,
Mm.
uh, which are like notorious. It doesn't happen that often, but like when it happens, like it's really disastrous.
Mm-hmm.
Um, and another one is like really out there, like this one that like I think Sam Ragsdale mentioned, and what he said was he would like to have like verifiable social media feeds. Um, so like if you're a Farcaster client and you're generating a feed based on whatever algorithm, I don't know, maybe you're just reverse chronologically serving it as a base case, or like you can do fancy machine learning, but then you can just prove it, like if it's reverse chronological order, you can just generate a proof that IDs are sorted whatever in descending order, um, or something like that. And if it's like fancy ML, then you probably have to do more work to verify it, but can be done, right? It's like
Yeah.
it can. So in that way, like um, well, I guess the social media user is not totally confused that like what is being served, why it is being served to me, and they can be sure of that, like some kind of deterministic recommendation
Mm-hmm.
system actually created this feed, so it's not totally random,
Mm-hmm.
or it's not maybe manufactured as psyop or something.
Yeah, yeah, yeah. Especially at the
uh,
client level, it's interesting. It's like these now. Yeah, there's this wide scope of verifiable compute, and it's like what is worth verifying. So you have like on one side, it's breaking down a lot of the stack essentially, and like verifying essentially like don't trust verify. Like it breaks down a lot of like trust assumptions, right? It's like you can have a more you know, better word, verifiable. You can trust the whole way because you can verify each of the steps and not just have to rely on the fact that your belief that they are executing in the code, like the supply chain example, right? Like it compiled right, and then it's going to do exactly that code. Or in this case, the feed is really interesting. I wonder if that would merge in. Like, do you see that coming with like Farcaster clients are going to start getting maybe hyper specialized like that podcast
yeah,
one.
I haven't fully followed the progress of zkML stuff,
Yeah.
uh, but I don't know, like um, maybe not in the near term. Uh,
Sure.
but like for instance, like if you think about Nook, have you tried Nook?
I haven't.
It's a
No.
Farcaster client. It's a Farcaster client that has like multiple timelines. Like you can customize your own timeline where you can add filters like give it channel names, give it some users, and then it aggregates the costs and serve it to you. So it has already has this capability of creating your own timeline. But then like you can think like in future uh, a no client can
Mm-hmm.
also make it verifiable. Uh,
Yeah. Yeah, because it's interesting. Sometimes we talk. It's like, what do you want to like verify, and is it like how valuable essentially is verification of something. So that's maybe
yeah.
an interesting one that we're starting to see a little bit more. Is there's topics of like algorithmic like transparency. The algorithm being separate. Let's say for something like TikTok is like if that were to be purchased, the algorithm is separate because they recognize how valuable it is, and it's kind of like their bread and butter is that their for you page just becomes so relevant for the users, and like kind of that's their differentiator. So it's interesting to then see algorithms and their impact on users be like really like recognized more and more. I even saw something. It was just a headline, but related to like New York potentially evaluating um, like algorithmic recommendations for kids, if that's
Mhm.
like the legality essentially of it. Because yeah, if you don't know, um, yeah, it's interesting to think about like the impact essentially like information sources or
Yeah.
feeds have on the users. So
Yeah, one other avenue where I see verifiable compilation uh, being deployed is like Etherscan, because when you try to
mm,
verify your contract in Etherscan, you have to like give them the compiler version that you use to compile your contract, and they compile it again and on their end, and then they publish the code, right? But like if you think like if you just create a proof while you're compiling and then upload the proof with the bytecode and the source code, then they just need to verify the proof,
mm,
and, and it saves a lot of computation uh, for them. So I think that's also an interesting use case of
yeah,
verifiable
that's a really
compilation.
interesting like kind of design space is like the reusability of proofs. Like you hear about like succinctness, but the
Mhm.
fact that once you do like create a proof, it can just be reused. So
Mhm.
hypothetically, if you had to do it on let's say like Etherscan, and you want to also do it for some other scan, and let's say
Right.
currently they have to compile it themselves. Yeah, there's just like scaling essentially of
Yeah.
reduction of work. So um,
Yeah.
that's an interesting thought. It's like something that feels like small, but you realize that like builds up to can reduce a lot of need for like unnecessary like double essentially computed, eventually like triple and so on.
Yeah.
Yeah, yeah, it's interesting to hear from people as well, like Justin Thaler and Sam, who you know pretty experienced and actually practical expertise in it, right? Putting it into practice with Joel. So it's interesting to
With
see,
Joe.
like,
Yeah.
I'm sure they spent plenty of times thinking about what's possible or what they would want to see. So it feels very like early as a whole. Like people are starting to figure out like what is most useful um, to start having like verification. One that gets brought up, and one that I've heard even from some of the use cases around zkTLS is like people talk about verifiability of like information, and then bots as sources of spam that maybe like, with some verifiability of like provenance that you can reduce like Sybil's and like Sybil attacks and things like that if you have some way to bringing up this like, anonymous credential sort of style
Mhm.
of with ZK is an interesting like area too. Is like like you're starting to see more conversations around, let's say, like bots, even on Farcaster. You know, there's a big conversation on Twitter when they're even looking at the number of like daily active users. Um, so that's I think a really interesting one, and maybe a good segue for zkTLS as well.
Yeah, yeah. Maybe like, do you want to give like an intro to zkTLS? I actually have like a question which is more related to, I think, opacity, their architecture. But like, yeah, let's first start with a basic intro, and then I want to ask this question.
Yeah, essentially, I guess like zkTLS is building on top of like TLS Notary, um, which is a way to sort of like verify session data. So like less abstractly, like data that websites use to serve information. Like, yeah, like let's say a business or service. Let's say something like Twitter is using their servers to actually like show data on your website or your like timeline. TLS Notary essentially allows a way to like have for like verification. Essentially, nice thumbs up on the on the data that is being served, and then zkTLS sort of builds on top of that, which now you can have privacy preserving. You get the benefits of zk with privacy preserving as well as like succinct, where you can prove any arbitrary data and to make it less abstract. Let's say everything essentially has to come from some sort of server or being stored elsewhere, right, on some sort of a database. And in that being shown, we're talking about verification of data and things like that like maybe even for like your Twitter profile, right? And you want to be able to show to someone that you have access, or you have X amount of followers, right, on Twitter. That's all being stored on Twitter servers, and it's essentially then being presented on a website. And now with like TLS Notary, you can have some sort of way to verify that, and then with zkTLS, you can do that in privacy preserving manner. People sometimes use the example with ZK of you go to a bar and you want to be able to show them 21, but you don't need to reveal maybe your hometown, your personal information, or anything else. You just need a particular attribute. So that's like an interesting aspect that we can get to by using zkTLS is.
Yeah, I also want to point out that the data silos aspect, because like a lot of Web2 data is kind of logged
For
in
sure.
Uber or Airbnb or like whatever social media, Facebook, Twitter, and you can basically liberate the data and put it in put it in like some kind of shared data uh, pool, maybe pour like a test to it and put it on a smart contract.
Mm-hmm.
Um, so that's also like pretty interesting that I like, if I'm like a Airbnb host and I have like whatever rating, and I want to move to a different platform, I cannot take my rating with me, but like with zkTLS, I can take that rating with me.
Mm-hmm.
So, which enables like a new competitor to Airbnb can really arrive and can bootstrap their network by asking their hosts to bring their ratings with them.
Mm-hmm.
And then once you have the supply side, you can get the demand going. So that part is interesting. It opens up, like, it opens a lot of opportunities to, like, once you can free that data from like corporate database, you can do a lot of things. So that part is also interesting to me.
Absolutely, that's an excellent point. I agree. I think that's personally the most interesting. Um, if I have to pick one, is like the aspect of there's way more data that already exists out there in the Web 2, and in those contexts, and it gets at the point of like a lot of like the switching costs, like the switching costs between services. Even we've seen with like social media, Farcaster is like it's maybe a little bit different because there's like network effects that are happening there, but is like you have all of this built up data and everything that comes from it, right? So as an example, like your ratings or like your reputation, right? Like reputation's this broad nebulous sort of thing, but the switching cost is really high because like he lives just on Twitter or like TikTok, Instagram, like whatever it might be. It kind of lives within that silo, and proofs are pretty cool because now it kind of feels like it makes the internet interoperable, like almost, and it doesn't. It opens the possibility of you being able to like have like seamless data, where in like the physical world you don't think about the fact that you have like different aspects of like, let's say, your personal life and professional life and everything like that. You don't think anything about when you go into work, you are still the same person because you're like physically the same person, but on the internet we're really like fragmented in all these different places across the internet. So like to your point, I think that's really exciting to think about is like actually opening up all this existing data that's out there and kind of like reduce the pressure almost on like users to just pick a service, and like because they've made that at some previous time and they want to switch, it's not really a possibility today. So that's a really interesting like space as a whole because it feels like I like to liberate the data with that. Yeah, so it's interesting because it maybe opens like some like aspects of like competition, but also like for innovation, hopefully, right? Yeah, that feels like a big design space, and it feels like a super ambitious potential, and I wonder what that sort of buildup of ideas is going to be. So I know like there's a couple different companies that are working in this. There's and I really like the term as well. It's like web proofs has been like discussed. I like that because it is very broad, but it feels pretty apt for like description of kind of what's possible. It's just like anything on the web that you want to prove. Like zkTLS can kind of like enable that. So you got like Pluto working on this as well as like opacity, right? And it's going to be very interesting to see what the approach is as far as like what it looks like in practice, right? In the same way that you're talking about Jolt and hearing like people who have actually implemented it, put it into practice. I'm really interested to see some of the applications that essentially come. We've seen some some more of like, let's say, some of the meme side of the internet with one of the hackathons from Opacity, which is funny, like being able to prove a position in GameStop, or being able to prove what percent of Neanderthal you are, or proof of bald. So there are a couple different like funny approaches. There's this wide space of like everything's possibly provable, and then realistically you gotta start with some subset of it. So I'm interested. Have you thought about like, are there any of particular interest of like that you've seen?
Yeah, that's the question I also wanted to ask you actually. Like, I'm not sure. Like, so there's one TikTok example that I heard that people are actually doing in practice. So there's this thing on TikTok where, like, if you're a content creator, you'd probably when you publish a new video, you'd ask your friends to hype it up a little bit, comment on it, and and the more hype that the video gets soon after it's published, the higher it rates, the more distribution it gets. So, and then like with these people, like what they're doing is they're creating like an informal group chat, and then they post their like whatever recent video they've published, and then everybody on the group chat is kind of trying to hype it up, and then they do some kind of revenue share. So if the content creator is getting paid like I don't know X amount, some of that amount they would pay back to the like to the person who's helping to hype it up and promote that. And so that opens a space where, like, if you want to prove that you're commenting on these videos and you're you're actually trying to retweet, like you have retweeted, you have commented, you can make a proof of these actions and give that proof to the content creator,
Mm-hmm.
and, and get paid proportionally uh, to whatever your however you have helped them promote their content.
Mm-hmm.
So, and I think yeah, I've heard from Opacity team that like a team is trying to build this TikTok solution, and I think they're probably getting some traction. So this one was interesting, and it's like completely completely out of left field for me, because like I'm usually not on TikTok and I don't know what's going on with the monetization uh, things there. So yeah, it was quite interesting. Uh, yeah, I'm kind of curious to know like what are other such domains where you could apply um, these things.
Mm-hmm.
Uh, yeah, I don't know if you have any use case in mind.
Yeah, I mean, there's a couple. There's a really, maybe right now it's like pie in the sky as far as how it's actually implemented. But I brought it up earlier. Was a thought of we're currently in this cookie sort of era of the web, and with privacy laws being and like essentially like the rights of like internet users kind of like growing, the moving away from cookies, and cookies are right now the bread and butter of like targeting for ads and advertisers, and for users hopefully then creating relevant content and things that they is like relevant for them ideally in an optimized market. And if we're moving away and now it has to be like first party data, I was wondering if maybe there's some way to start to do like a sort of like cookieless future but still get the benefits of like targeted ads in a privacy preserving way with zkTLS. And it's very, very broad right now, but it was just getting my head spinning, wheels turning, kind of thinking about there's potential for this. It's like you could maybe prove what websites you visited, and as some
So
sort of
you don't want to like have third party cookies in your browser, um, or
they just it's just being it's like not even like a personally I don't, but also like it's broadly being applied that advertising is moving towards like a first party data model. So essentially the data that you get to use to be able to, let's say, serve relevant ads or even let's say get content, right, if, is just off of like what a user gives to you. So like now you always will see like at least in the U.S. They'll have like accept all cookies, like reject some, or like only necessary. And the benefit when you accept all is that the service has increased like data that you essentially can give. So maybe it's from like previous other websites to try to like have a better understanding of, okay, like you've gone to different sports like websites recently, and like you're on ESPN, maybe I'm going to show you a targeted thing for some sort of like sports related apparel or like jersey, something along those lines. Is like advertising works based off of like the groupings of like some sort of overlaps of interest. And I was wondering if there would be some way, because everything has to like is having to move. I think Google itself is phasing out cookies. Maybe it's 2025, but they're currently in the process of doing it. So like this creates a really tough problem for advertisers because they don't have any access to data, to which has been the like bread and butter of like how any of these things work. So they have to rethink, how do you get this data? So I was wondering, and there'd actually been a company that had been working on this, like a similar sort of space, is like getting paid essentially for your data. So I wonder if maybe there's some marketplace that kind of like eventually will open up, and maybe it's not just. I don't think anyone's just gonna opt into like some marketplace, like go out of their way to do it. So I wonder like how maybe individual websites would do this, where they like offer some sort of like payment. Maybe it's a subscription, but to the user, where it's like I'll pay you $5 a month to be able to like continue to get access to certain data, like web use data, because it can be very useful for users. Is that's like, you know, it in an ideal world, it sort of like creates like, you know, you have goods and services and like you get the demand for it on the user side, so you probably want maybe something potentially, and fortunately a lot of these companies are good with their recommendation algorithms and things like that, targeting, you know, they've figured out that whole space. So I wonder if there's, you know, some potential for like a privacy preserving way where like users essentially are able to opt into it, versus right now, I think we're just kind of young in the internet as a whole, and people are beginning to like recognize the impact that, you know, sharing data just generally has, but also those like rights are kind of being established with, like, you know, maybe GDPR being one of the most prominent sort of chapters in internet. So
But do you think that like with like in the future, the ads will be more targeted or less targeted?
it depends on maybe what path. Yeah, I don't know. There's a couple of options. I would like to say more targeted, because we are like continuing to grow in like what we can possibly do, right? Like increase compute, like our models are getting better. So then as a result, the models, what they're doing is like trying to increase, you know, the relevancy or maybe the click through or whatever it might be of an ad. So I think that there's potential for it, but there's also like a weird vacuum that might get created. I feel like if all of this data, you know, sort of goes out the window, is then now companies are really facing like data, like the actual drawbacks of data silos. Is that, you know, it's powerful when you have data, but if you don't have access to it, then you're going to get like decreased relevancy essentially for the content being shown, and maybe as a result like less dollars being paid or gone through on like your platform. So I would say that it's likely that we're going to get continued like, or like increased targeting. I do hope that it turns into like maybe a little bit more of a user you know, opted in essentially level and granularity, like not to the complete side of like where all of the convenience is out the door, where like I don't think an individual is going to want to have to like at every single website or every single time like do some sort of like opting in, but maybe some sort of some, at least an option essentially for users to be able to like opt in or opt out,
Yeah.
and essentially use these like recommendation algorithms like in their favor and not just be completely targeted. So we'll see. I feel like companies are almost like scrambling right now to try to figure out how they approach this like cookieless future. So that's a really
Yeah, one thing with zkTLS, like another interesting bit about zkTLS is that, like, you know, it cannot like if a company like Airbnb try to stop uh, like a person exporting their own data, like they cannot like practically do it, because essentially what they see is like, you know, it's just the TLS connection is very similar to how it would be for any other client. So it might be slow because it has to run this two-party computation, but like it's not that slow that they basically get zero signal, so they cannot terminate that connection. And I was just wondering the other day, like what happens when these company um, they find out that people are exporting the data and then moving to some other network, their competitor. And I was just like curious, like how they will handle how they will handle such scenarios. So like I asked this question in the ZK channel in Farcaster, and like there were like few responses. Um, some of them said that like, yeah, of course these companies will try to stop as soon as they find out, and others were like, you know, they won't be able to find out, and like they keep on fighting, but like they cannot compete because essentially like users, like if they want to leave they can leave because Yeah, that's what zkTLS would let them do. So that's an interesting thing to like. I don't know. I think like right now they probably don't have a clue that like their data monopoly could be like they
Mm-hmm.
could be threatened. But like I don't know, like if even if they have a clue, like what can they do about it?
Mm-hmm.
It's also an interesting idea.
Yeah, it is. It's a weird one because you don't think it wasn't a possibility, like thinking that that's feasible. But like, yeah, like you said, there's not really, from my understanding, like a clear way that someone can detect that happening.
Yeah.
So because it's the same information that they're displaying, you know, they're not treating it any differently. So it's not like a way to
As
detect it.
as long as you run zkTLS from the client, they cannot detect it. If you try to run it via server, like they can potentially block that IP because if one server is making too many connections and trying to export data, that sounds uh, yeah, I mean they could detect that pattern and then shut it down. But
Mm-hmm.
like if every client individually exporting their own data and then putting it back together in some other network, I think that's yeah, but that's like you can totally do that. Like it's like a coordinated exodus uh, from one network to another.
Sure.
Uh,
Yeah,
yeah,
that's it. It would like it's interesting to think about what the different benefits essentially, like why someone is going to decide to create a web proof. Essentially, it's like there has to be some meaningful like value created for them to do so. So I'm really interested to see kind of like how different companies
yeah.
or applications that are using
The
these.
first thing that comes to mind in that regard is the high take rates because like some platforms just they charge too much. Like they take I don't know what the take rates are, but like usually it's pretty exploitative for the content creator, right? So if the next platform comes and says like whatever if the earlier one was charging like was taking 25% of the revenue for themselves and the new one comes and takes only 10%,
Mm-hmm.
like everybody would be happy to move, right? They just need their
Yeah.
data, they just need their ratings, they just need their social graph, and they can just move.
Yeah, those are some big pieces. Just and hopefully we find some way. Yeah, I like the concept of liberating the data. I think that's a good. It humanizes it as well. It's interesting. Yeah, what's maybe um, possible there? Yeah, because like the big like let's say even switching costs. I think like Farcaster like an interesting case study to maybe think about it because like these things are possible with a permissionless protocol is the network, right? It's a social network. Like that's kind of what brings it like value, right? So the switching cost right now is kind of if conversations are happening on Twitter versus Farcaster, then the switching cost is like high for users. So figuring it out and like working backwards from maybe what some of the pain points are. Um, so it seems like there's like some interesting like product design space. Yeah, like TikTok marketing wouldn't have been the first that I thought I thought of when I hear zkTLS, but it's interesting to see what really opens up with this, and I'm glad it's also like some product focused like applied cryptography. Like that's great to see. So I'm excited to see kind of how it all develops because it's so like new, right? Like, I don't know how many of these are even like let's say production today, but a lot of them are in test net. So
Yeah,
I'm sure we're gonna be seeing like more and more, and plenty of other ones that maybe we couldn't have even thought of until it exists.
yeah,
Yeah, I don't know as well. I mean, I guess we kind of ran through a little bit of like the zkVM design space as well as like zkTLS. I think
yeah.
this.
zkVMs are interesting, right? Because like every month there's new one. Yeah, it's like yeah, it's quite funny that zkVM actually started in the EVM space,
Mm.
right? Because earlier, like I don't know, maybe around 2019, Ethereum went into this roll-up centric roadmap mode,
Mm-hmm.
and teams started to build the roll-ups, and then like you could build the optimistic rollup or a zk rollup, but like it's pretty clear that like eventually like the end game is zk. So uh, yeah, and like yeah, if you're trying to build like an EVM compatible uh, VM, and you want a validity proof from it, so you want to like make a zk EVM. And I think that's how the projects like zkSync started, right? Because they wanted to build a rollup, they wanted compatibility with the EVM,
Mm-hmm.
and I think now they're probably in production. I haven't deployed anything on zkSync, but I believe they are like EVM compatible. So I think that's how it started. And another one is Scroll.
Mm-hmm.
I think they are also zk EVM. And then like we saw some projects which are not EVM compatible, like Cairo. Uh, Startnet had their own VM, and and it's like yeah, they have their own language. It produces similar validity proofs. And what's interesting about that approach was that people thought that like if you're building a new VM, you should like customize it in such a way that it's optimized for snarks, for validity proofs. But then recently, what we saw is people actually building validity proofs in RISC-V VMs, which is interesting, right? Because earlier they thought that like to to make an optimized proving VM, you need to have like a customized ISA just for that.
Mm-hmm.
But then they came back to like a very standard ISA, which is RISC-V,
Mm-hmm.
uh, kind of started with RISC-0. So it's interesting to me that the right answer was always to pick a standard VM and not invent whatever Cairo or any other VM design.
Mm-hmm.
But yeah, so the all the new ones like RISC-0, Succinct, Jolt, they're all based on RISC-V ISA. And yeah, it's interesting that like yeah, they're like this good enough competition, because I think RISC-0 and Succinct are pretty much same. They have this Stark based proving system, uh, but Jolt is quite different. Um, they they are based on this. They uses lookup tables a lot, uses sum check, which is quite different than what we used in RISC-0, I think. So in the yeah, I think I'm rambling at this point, but like it's a zkVMs are interesting because like uh, yeah, it feels like there's an abundance of infrastructure right now in that area,
Mm-hmm.
and yeah, it's sort of a right moment to think about what one should actually be building with those with that kind of infrastructure.
Yeah, absolutely. There's, I mean, 2019 is not that long ago, so it's crazy to see the amount of development and like effort that is going into the whole space. But I realized that that was like the sort of the zkEVM was the maybe the catalyst, it sounds, for like zkVM just development as a whole, which is like an interesting like context to have here. Yeah, because now it feels like there's plenty of horses in the race with the zkVM space, and then yeah, get some applications. It sounds people are starting to actually being able to like use it, and yeah, abstraction kind of just wins. So I'm glad that's the case. I don't want to have to write circuits for everything that you want to verify. So zkVMs are a massive unlock there for sure.
Yeah. There's also an interesting debate which is going on a little bit, is whether you should make whether you should have bespoke circuits for your different computation, or you should have a VM that could prove any kind of computation.
Mm-hmm.
I think some people who want to like create bespoke circuits, I think their point is you can really hyper optimize for your use case. You don't need, like, if your use case is small enough, then you don't need the whole VM. Uh, for that, you can really make a small circuit and make it really optimized. But then the other argument is basically you have this VM and you can just do anything with it, and it just uh, makes it very easy for a developer to program in a higher level language, which could be compiled to run on this VM.
Mm-hmm. Yeah. Is there? Yeah. How do you keep up with all of this? There's so much within the space, and it feels you can't pay attention to everything. Do you try to
Yeah,
follow particular people or like articles,
yeah.
sources?
So for me, at least, yeah, Twitter. Uh, I just yeah. There are like some teams which usually put out their progress reports. Like the Polygon has a couple of ZK teams, right?
Mm-hmm.
The Biden, Polygon ID. Uh, so I try to follow the status reports of what's going on with the teams.
Mm-hmm.
Similarly with the zkVMs, you have risk0, you have succinct, you have a16z crypto, and yeah, pretty much just by following the teams and what they're putting out.
And then how do you find new teams? I guess because it feels like there's always new entrants.
Yeah,
Is that
I
just
think
manual?
GitHub feed is quite interesting for me, because like I typically follow these organizations and people who are creating, like, once I follow the organizations, I see their releases on my timeline. Then I click on their releases, look at the PR, and follow the people who are making those PRs.
Yeah.
So it's kind of uh, yeah, just and then then I get more recommendations for people like that and the repositories like that. So yeah, because like it's really hard for me to follow the research, because I'm not gonna read all all the papers. Like, I'm not a cryptographer
Mm-hmm.
and I'm not even a mathematician or anything. Basically, when I try to read any cryptography paper, like 70%, like I just skip the 70% of it and just read the pseudocode and try to just make sense of the pseudocode and try to implement it for my understanding.
Mm-hmm.
But I really just don't try that much uh, to follow ePrint or those kind of
Mm-hmm.
journals. I just yeah, I just try to follow people on GitHub and see what they're releasing.
Sure. Get it like that approach. Get it directly from the source.
Yeah, yeah,
That's sweet because yeah, it's a tough problem in anything that rapidly sort of moves like crypto or zk. So it's interesting to hear. GitHub's a pretty good, I feel like an underrated way to stay up with
yeah.
these projects.
GitHub timeline is pretty underrated in my opinion.
Mm-hmm. Yeah, for sure. I guess, I mean, I feel like we've covered a fair bit of ground here across
Yeah,
zkVMs and zkTLS, which I really enjoyed, and some learning some new context too for even the evolution, I guess, of zk VMs. But yeah, this was great. I'm glad. I'll have to maybe follow up and see what GitHub orgs I should be following as well.
yeah. I would recommend following the repos and the projects directly on GitHub.
For sure. Well, sweet. I don't know. I guess we can kind of wrap up stream unless there's anything else you wanted to mention here.
No, I think that was pretty much it. Like, I really enjoyed.
For sure.
talking about these topics. Yeah, maybe we can do it next time
Mhm.
and cover a few more new stuff as it comes.